Okay, I'd like to do a quick review of all of the sections that you were asked to read in your distance learning packets week 1 through week 3. So the first section was about gravity on Earth. Have you ever heard the saying, what goes up must come down? Everything falls downward or toward Earth's center because of gravity. Gravity is a force that pulls one object toward another object. Earth's gravity pulls objects toward the planet's center. One factor that affects the strength of gravity's pull is the distance between the two objects pulling on each other. Earth's pull on objects farther from the surface is less than it is on objects closer to the surface. So let's take a look at this skydiver. So you can see that the air is pushing up on him and gravity is pulling down. And so he ends up looking like he's flying. And you can see in this animation, Earth's gravity pulling anything, including a skydiver, toward the center of Earth. So the next section is called Earth, Sun, and Moon. Two of Earth's close neighbors in space, the Moon and the Sun, form a system with Earth. They move independently and as a system. All three revolve or move around other objects. Earth revolves around the Sun, and at the same time, the Moon revolves around Earth. The Sun, Earth, and Moon together revolve around the center of our galaxy, the Milky Way. The motion of one object around another is called revolution. The Sun, Earth, and Moon revolve as a result of gravitational force. This force pulls objects toward each other. The gravitational force between Earth and the less massive Moon keeps the Moon moving around Earth. The gravitational force between Earth and the Sun keeps Earth revolving around this massive star. So basically, just like the Earth pulls on that skydiver, the Earth also pulls on the Moon, and just like the Earth pulls on the skydiver, the Sun pulls on the Earth. So in that situation, the Earth would be more like the skydiver. So gravity is a thing that's applicable in all of those situations. The next section is entitled Our Star, the Sun. A star is a ball of hot gases that give off light and other types of energy. Stars range greatly in size and in the amounts of light and energy they give off. Even though the Sun appears to be quite large to us, it's really only a medium-sized star. The Sun appears larger and brighter than other stars in the sky because it is the closest star to Earth. It is so close, in fact, that its brightness blocks out the light of larger and brighter stars that are farther away. That is why you can't see stars during daylight hours. So let's take a look at this video. So there's an amazing video of the Sun. And there's a view from Easter Island in Chile up into the beautiful night sky. And you can see a lot of stars there and the Milky Way. So the next section is called Day and Night. Think about what happens when you rotate or spin around. As you turn, you face different directions and see different things. Places on Earth are like that. Earth does not stand still. It rotates on an imaginary line called an axis and runs through the North and South poles. Half of Earth always faces the sun and is lit by sunlight, and there it's day. The other half of Earth faces away from the sun and is dark, and there it is night. Earth makes one complete rotation approximately every 24 hours. That is why one complete day and night cycle lasts 24 hours. So here's a video of the International Space Station, which shows kind of a quick version of day and night. So the space station's moving around Earth very quickly. So now it's coming into a section of Earth that is lit by the sun. So here it's day. And pretty soon you're going to start to notice that the Earth gets a little dimmer and dimmer and dimmer, and then suddenly you're going to notice, oh, that must be the other side that is now facing away from the sun, and that is nighttime. Super quick in that video. So the next section is entitled Apparent Motion. The people on this ride are moving in a circle. When they look outward, the people standing still on the ground appear to be moving, but the bystanders have only apparent motion, or motion that seems to happen. Like the turning ride, Earth's rotation causes some apparent movements. As observers look outward, they see the apparent motion of the sun across the sky from east to west, but it is Earth that is actually turning instead. Like the sun and moon, many stars appear to rise above the horizon and move in an arc shape across the sky. In the northern hemisphere, stars high in the sky appear to move in a circle around the North Star. So the image on this page reminds me of the merry-go-round that many of you have probably ridden here in Palm Beach Gardens, and you can see apparent motion there. Let's see this video. And there you can see the night sky, and also part of our galaxy, the Milky Way. So the last section is called Revolution and the Seasons. You can't feel it, but Earth moves. It rotates around its imaginary axis, which is tilted at an angle. Earth also revolves or follows a regular path around the sun. The path a revolving body follows is its orbit. Earth's tilt on its axis and its revolution around the sun cause observable patterns called seasons. Weather and the number of daylight hours at most places on Earth change with the seasons. Earth's tilt on its axis also causes the seasons to be opposite in the northern, which is us, and southern hemispheres. For example, when it's summer for us here in the northern hemisphere, it's winter in the southern hemisphere. Study the diagrams to see how Earth's changing position causes the seasons. The captions describe seasonal changes in the northern hemisphere. Note that the sizes of Earth and the sun and the distance between them are not to scale in the drawings. And you can imagine why the drawing cannot be to scale, because the distances are so huge and the sun is so large. And so is Earth, but the sun is so much larger. The other thing I want to point out to you about the seasons that you already know is that it's a little trickier for us here in Florida, because We do have seasons, but they're not as pronounced as they are, say, in maybe New York or Connecticut. So let's take a look at how the seasons change in a place like that. So there's spring, summer, and you can see the tree, fall, which unfortunately we don't really get here in Florida, and winter, which we definitely almost never get snow like that. It's so beautiful. So that's the last section, and a quick review to help you when you complete your assignment.